half of the world's population. At global level, rice is the second most important crop after wheat. In fact, India is the largest rice growing country in the world, and almost all the states of India are cultivating rice. Before taking up seed production in any crop, precise knowledge on the floral biology of that crop is quite essential for planning and successful implementation of seed production program. Therefore, let us first familiarize with the floral biology of rice crop. Botanically, rice is known as Oryza sativa, belongs to the family Poaceae. Rice is the self-pollinated crop with cross-pollination occurs to an extent of up to 4%. Inflorescence is a panicle borne on the peduncle of the last internode. The main axis gives rise to primary branches. From the primary branches, secondary branches arise. Rarely, tertiary branches are seen. Spikelets are borne on primary and secondary branches. The number of spikelets borne on primary branches shows no variation. It is the number of secondary branches on a panicle that contribute significantly to the total number of spikelets, and it may vary from 80 to 300 in panicle. The individual spikelet consists of small rachis in which two rudimentary glumes are born. Above the glumes, lemma and palea are present, which represent bract and bracteole respectively. The lemma is 5-nerved, leathery and boat-shaped. The palea is 3-nerved. The lemma and palea enclose the gynoecium and androecium. A pair of lodicules represent perianth. The androecium consists of 6 stamens, bilobed anthers, basifixed, linear and pendulous. The gynoecium consists of superior ovary, monocarpellary, unilocular and 2 styles with plumose stigma. In a plant, the panicle emerges 4 to 5 days after the boot leaf is completely emerged out. The flower opening starts from the tip of the primary and secondary branches and proceeds downwards. Normally, 6 to 8 days are required to complete flowering in a panicle. Under normal conditions, flower opening is between 7 and 10 am. The flower opening gets delayed on humid and cloudy days. The flower remains open for 10 minutes and afterwards it closes. The dehiscence of anthers is independent of spikelet opening. The dehiscence may take place before opening of flowers or after opening of flowers. The stigma is receptive for 3 days and the pollen grains are viable for 10 minutes under field conditions. In rice, seed production is done in both open pollinated varieties and hybrids. Seed production in varieties is very easy as compared to hybrids. For varieties, parental lines are sown or planted in isolation and allowed to open pollinate to set seeds. Contrary to the varietal seed production, hybrid seed production is highly skill oriented and more technology is involved. You all aware that a hybrid is defined as the first generation progeny of a cross between two genetically different identical inbred lines. The individual lines are known as inbreds. Ineffective cross pollination is a major constraint in commercial hybrid seed production in many crop species. Rice being a highly self-pollinated crop, cross pollination is a big problem. Availability of suitable pollination control mechanism is a key factor determining the success in commercial hybrid seed production. In hybrid seed production, mainly two types of breeding systems are being followed. The first one is 3-line breeding system, otherwise known as cytoplasmic genetic male sterile system. In this system, 3 inbreds, namely A line, B line and R line are involved in hybrid seed production in different stages of seed multiplication. A line is a male sterile line used as female line which does not produce functional pollen to set the seeds on its own. However, when this A line is crossed with male line, that is R line, otherwise known as restorer line, which restores the fertility in A line and sets hybrid seed. Multiplication of A line can be done by crossing the A line and another male line called as B line, otherwise known as maintainer line, which is the fertile counterpart of the A line. This A line or cytoplasmic genetic male sterile line should have complete pollen sterility to avoid self-fertilization, and pollen sterility should be stable at different environments. It should have a fair to good general combining ability, agronomic potential and good adaptability to cultural practices. The second type of breeding system adopted in rice hybrid seed production is two-line breeding system. In this system, male sterility occurs depends on photoperiod and temperature prevail in the production location. Since the environment plays a vital role in determination of sterility or fertility status of a line, this system is known as environmental sensitive genetic male sterile system. This system involves only two lines, that is male sterile line and pollinator line. Seed production in this system is easy and economical. The maintenance of genetic purity of male sterile line is very important and much more critical in this system than the three-line breeding system. Seed multiplication is usually done in definite system known as generation system of seed production. It involves different stages of seed multiplication known as nucleus seed, breeder seed, foundation seed and certified seed. This generation system can be altered depending on the demand if warranted. Selection of suitable season for the chosen variety is very important to obtain good quality seeds. For hybrid seed production, Rabi season from December to April is highly suitable when compared to Kharif season from May to August. Seeding of parental lines should be done in such a way that flowering and harvesting of seed crop does not coincide with rain. In hybrid seed production, favorable climate condition during flowering are highly essential for higher seed set. The daily mean temperature should be between 24 to 30 degrees centigrade with a relative humidity of 70 to 80%. The difference between day and night temperature should be 8 to 10 degrees centigrade. There must be sufficient sunshine and moderate wind velocity of 2 to 3 meters per second. Seed set and seed yield will be affected if temperature is below 20 degrees centigrade and above 35 degrees centigrade during the time of flowering. The land selection for seed production is very important. The selected land should be free from volunteer plants. When space isolation is not possible, the time isolation of over 21 days or barrier isolation with polythene sheets of 2 meter height or tall growing barrier crops like sesbania, sugarcane and maize covering a distance of 3 meters would serve as isolation from nearby contaminating sources. The seeds used for raising a seed crop should be of known purity, appropriate class and should have been obtained from authentic seed source with respective class, certification seed tag and receipt. Depends upon the duration of variety and method of cultivation, the seed rate required for unit area may vary from 10 to 60 kg per hectare. It is important to use adequate quantity of seed rate to maintain optimum plant population in the field. For hybrid seed production, seed requirement will be 20 kg of A line and 10 kg of R line per hectare. The seeds are sown in nursery bed and transplanted in main field. Before sowing the seeds in the nursery, it is good to upgrade the seeds on weight basis by density grading using common salt solution having a specific gravity of 1.13. For this, 1.5 kg of common salt is dissolved in 10 liters of water and seeds meant for sowing are dropped in the salt solution. The heavy seeds that sink at the bottom of the container are to be collected and rinsed with water thoroughly. Sometimes freshly harvested seeds which are still under dormancy need to be sown to meet the production requirements. In such cases, to break the dormancy, seeds may be soaked in 0.5% potassium nitrate or 0.1 normal nitric acid at 1:1 volume of seed to solution ratio for 12 to 16 hours. The seeds may then be air dried to original moisture content. Before sowing, seeds may be given seed treatment to withstand various biotic and abiotic stresses in the field condition. For dryland and upland rice, seed hardening may be done with 1% potassium chloride. For protection against seed or soil borne pathogen, the seeds are treated with fungicides like Capton, Thiram, Carbendazim at the rate of 2 gram per kg of seeds. 24 hours after treating the seeds with fungicide or before sowing, seed coating with azospirillum at the rate of 600 grams could be adopted. The treated seeds ready for sowing in the nursery should be pre-germinated for better establishment in waterlogged nursery condition. For this, the seeds are held in loosely tied gunny bag and soaked in water for 24 hours. Then the seed bags are tied tightly and incubated in dark for 12 hours or overnight. White protrusion of radicals from the seed expresses the pre-germination of the seed, and these seeds are sown in nursery by broadcasting. For raising 1 hectare of seed crop, 20 cents, that is 800 meter squared area are required. For raising more varieties in the same place, separate irrigation channels are to be prepared for each variety to avoid admixture of seeds and to maintain the genetic purity. For hybrid seed production, female and male nurseries should be raised separately. Sparse sowing in nursery bed at the rate of 1 kg per cent should be practiced to obtain robust seedlings. Application of DAP at the rate of 2 kg per cent is essential. Basal application of DAP is recommended when the seedlings are to be pulled out in 20 to 25 days after sowing. If seedlings are to be pulled out after 25 days, application of DAP is to be done 10 days prior to pulling out. In case of clayey soils where root snapping is a problem, DAP has to be applied at 1 kg per cent 10 days after sowing. In hybrid seed production, staggered sowing of parental lines should be done for proper synchronization in flowering of male and female parents. As the seed set in female line depends on amount of cross pollination occurs, it is most important to synchronize the heading date of male and female parents, especially for the hybrid combinations having parents with quite different growing duration. In addition, in order to extend the pollen supply time, the male parent is usually seeded twice or thrice at interval of 4 to 5 days. To determine the differences in seeding date between male and female parents, 3 methods are practiced. The first method is growth duration difference method. The second one is leaf number difference method, and the third method is effective accumulated temperature method. It is always advisable to transplant optimum aged seedlings to ensure maximum growth and productivity of crop. The optimum age of seedlings for short duration varieties is 18 to 22 days, 25 to 30 days for medium and 35 to 40 days for long duration varieties. For hybrid seed production, 25 days old A-line seedlings and 14 to 20 days old R-line seedlings can be transplanted. Before transplanting, the seedlings are to be given root soak treatment with 100 ml chlorpyrifos 20 EC and 2.5 kg urea dissolved in 50 liters of water for 20 minutes. The seedling should be transplanted at optimum spacing and depth at 4 to 5 leaf stage. Seedlings may be planted at uniform depth of 3 cm with a row to row spacing of 20 cm and plant to plant spacing of 10 to 20 cm depends upon the varietal requirement. For breeder seed production, double row planting with a spacing of 15 by 20 cm has to be adopted for easy rowing operations. In case of hybrid seed production, two parental lines, that is male and female lines, are to be transplanted in a systematic manner at appropriate planting ratio to facilitate outcrossing. Practically, the planting ratio of 8:2, that is 8 rows of female and 2 rows of male lines currently being adopted for hybrid rice seed production. The male and female rows in the seed production plot should be perpendicular to the prevailing wind direction expected at the time of flowering. Let us now learn in detail how the male and female lines are transplanted in the main field. The male lines or R-line seedlings are transplanted in paired rows of 30 cm apart. In case of two staggered seedlings of R-line, the first and second sown R-line seedlings may be planted in two separate rows at 15 cm spacing, or the first sown seedling may be planted in both the rows with 30 cm spacing, and second sown seedlings may be planted in the middle of the seedling in both rows. Whereas in three staggered seedlings of R-line, all the seedlings may be pulled out separately, mixed together thoroughly by spreading one over the other, and planted in two paired rows at 2 to 3 seedlings per hill with 15 cm spacing within the rows. It is more convenient, easy and labor saving method in case of large scale seed production. By proper synchronization, higher seed set and yield have been recorded in three staggered seedling of R-line. The female or A-line seedlings are transplanted in blocks of 8 rows in between the paired rows of R-line seedlings. Transplant with one or more seedlings per hill with inter and intra row spacing of 15 by 15 cm in 145 cm wide block, or 10 by 10 cm spacing in 110 cm wide block according to fertility level of selected field. Leave a 20 cm spacing between the A-line rows and the nearest R-line row. All the 4 sites of hybrid seed production field should be planted with 4 lines of border rows with the same male line used in the main hybrid seed production field to ensure an adequate supply of pollen and to trap undesirable pollen incoming from other fields. Balanced and timely application of organic manure and optimum doses of major and micronutrients helps in production of higher quantity of good quality seeds. Optimum application of nitrogen fertilizer is found to increase the protein content, which in turn increases the germinability and vigor. Similarly, application of phosphorus and potassium increases the germinability, vigor and storability of seeds. Hence, the recommended dose of N, P, K has to be applied at appropriate growth stages for the varietal and hybrid seed production. The entire dose of phosphoric fertilizer is always added at last plowing stage. However, the nitrogen and potassium are applied in 3 split doses, namely at basal, active tillering and panicle initiation stages. Application of micronutrients is also advocated to improve the flowering, seed set and seed yield. Application of zinc sulfate at 25 kg per hectare is recommended for seed crops to increase the flowering and seed set. Application of gypsum at 500 kg per hectare is also recommended to increase the yield in rice. To enhance the seed set in rice cultivars, foliar spraying of 2% DAP at the time of flowering is recommended. In case of zinc deficient soils, foliar spraying of 0.5% zinc sulfate thrice during crop growth stages on 20th, 30th and 40th days of planting for short duration varieties, and 30th, 40th and 50th day for medium and long duration varieties is advocated. Based on the morphological features, the young panicles are classified into 8 development stages. The synchronization in flowering can be predicted by using such criteria. In practice, about 30 days before heading, the male and female parents in the seed production field are sampled and their young panicles within the main clump are carefully observed with the magnifying lens every 3 days. Usually, female and male parents will take 27 and 32 days respectively from panicle initiation to heading. Method of observing panicle initiation is very simple. Select the main tiller, that is longest one, and cut at the base where the stem and root join. Make a longitudinal slit from the base up to top of the tiller, then open the slit just above the nodal portion and observe the developing panicle with the help of a magnifying lens. This has to be done in both the parents to determine the synchronization or non-synchronization of heading date. In case of variation in flowering or heading of male and female lines, necessary steps are to be taken to adjust the flowering date for synchronization of flowering in male and female lines. To delay the advancing parent, 2% urea is sprayed with knapsack sprayer at 500 liters per hectare. Application of 35 kg of urea per hectare, draining water from field, removal of panicles from early developing parents and leaf clipping can also be advocated. To advance the delaying parent, spray 2% DAP solution and retain higher standing water in the field. In some of the hybrid combination, the panicle exertion in female parent is incomplete. About 25 to 30% spikelets of a panicle are inside the flag leaf sheath in most of the Indica male sterile lines than that of Japonica male sterile lines. Good panicle exertion will help in improving the seed set. GA3 plays an important role in enhancing panicle exertion of male sterile lines. It can adjust the physiological and biochemical metabolism of rice plant, especially by stimulating the elongation of young cells. Timing and frequency of supplementary pollination is very important. Supplementary pollination should be done at the peak anthesis, that is when 30 to 40% of spikelets are open. This process is repeated 3 to 4 times during the day at an interval of 30 minutes. Supplementary pollination has to be done for 7 to 10 days during the flowering period. Supplementary pollination in hybrid rice can be done in 2 methods, that is rope pulling and rod driving. In rope pulling method, 2 persons can hold the rope at either end and pull it gently over the surface starting from the border rows and entering the hybrid field. The rope is pulled along the row and not against the row. It is carried out at 30 minutes interval for 5 times daily, both in the morning by 10 am to 12 noon and afternoon by 2 to 4 pm for 6 to 7 days until no pollen remains on the male parent. It is extremely necessary on calm and breezy days compared to windy days. Timely and adequate roguing is extremely important in seed production. Removal of off types, rogues, volunteer plants, objectionable weeds, insect and disease infected plants must be done at every stage of crop growth, namely vegetative, flowering and harvesting, to avoid genetic and physical contamination. In hybrid seed production plot, the undesirable plants, both A and R line rows that differ from plants that are true to type, are to be removed. The pollen shedders, that is presence of B line plants in A line rows, are also to be checked and removed to maintain genetic and physical purity of seeds. The most important stages for roguing are maximum tillering, flowering and before harvesting. The seed crop should be harvested at optimum stage when the seeds will have maximum germinability and vigor and minimum moisture. Turning of green seeds to straw yellow color is the stage of physiological maturation in rice. The earhead should be harvested when the seeds have attained maximum physiological maturity. When the panicles turn to straw yellow color, the yellowing of plants is activated. At this stage, the irrigation to the seed production plot is withheld and this hastens the drying of the plants and seeds. The crop is harvested as once over harvest, as uniformity will be maintained in earheads on maturity. In hybrid seed production plot, male and female lines should be harvested separately. The male rows are harvested first and transported to separate threshing floor. Like that, female rows are harvested and threshed separately. Care should be taken to avoid admixture of female and male lines during harvest. The harvested plants are staked in a clean threshing floor. The moisture content of the seed at the time of threshing will be 15 to 18%. Small quantity of produce or breeder seed stock can be threshed manually by beating against hard surface. For large scale production, mechanical threshers are used, but care should be given to avoid mechanical damage, which in turn will reduce the seed quality and storability. The seed should be dried to safe moisture content of 10 to 13% under normal drying conditions. To get physically pure uniform size seed which fetch high price in the market, suitable sieves and methods are to be followed for processing the seeds. The chaff, ill-filled, undersized and oversized seeds are to be removed to maintain the physical purity of the seeds to 98 to 100%. Mechanical grading can be done with cleaner cum grader, which will remove the undersized, immature and chaffy seeds. The size of the sieve can be changed depending upon the type of the seed to obtain physically pure and uniform size seeds. Normally, rice seeds are not treated with chemicals owing to their economic utility. However, for long-term storage, seeds can be treated with carbendazim at the rate of 2 gram per kg of seeds. As a prophylactic measure, seeds can be fumigated to have a check over storage pest. Before fumigation, one must ensure that the moisture content of the seed is not above 10 to 12%, which may interfere with the seed quality in terms of germination. According to Seeds Act 1966, all the seeds of notified kinds and varieties when sold to the market must meet minimum seed certification standard for germination and physical purity. Rice seeds should possess a minimum physical purity of 98% and minimum germination of 80% as per the Indian minimum seed standards. The seed lots meeting the seed standard should be packed in a suitable container affixed with the label containing information on class of seed, variety, lot number, germination percent, physical purity percent, name of the seed producer, date of test and validity particulars. The germination percentage as given on the label is valid for 9 months and after which it has to be revalidated. After packing, seeds may either be sent to the market for sale or stored safely till the next season. Rice is a good storer. Generally, rice seeds store well up to 12 to 24 months depending upon the genotype. However, heavy infestation of storage pest may reduce the storability of seed even to a month or two. For normal storage, jute canvas bags are used with seed moisture content reduced up to 13%. For prolonged storage, HDPE bags, polylined gunny bags or moisture vapor proof containers are to be used with maximum permissible moisture content of 8%. Seeds are to be stored in well maintained storage godown on the dunnage to maintain the shelf life of seeds for long time.